So in this video, we'll be focusing on how to find the surface area of 3D shapes. Now, a common mistake that people make when asked to find the surface area of a 3D shape is thinking that it means what it suggests. Many think that you are asked to find the area or the side or the face that touches the surface, and this is wrong. So what I mean by that is when people, a common misconception or a mistake that people make is when asked to find the surface area of a shape, then what they usually go for, and if we look at the cuboid on the top of the screen, is they work out this area here, or on the triangular prism, this area here, or on the cylinder, this area here, because they would be the faces that actually touches the surface, and that is incorrect. Now, typically we can work out the area of flat surfaces, so when we are asked to calculate the surface area of a shape, actually we are asked to find the area of all the faces of the 3D shape. Now imagine you are wrapping a present, so the surface area is the smallest amount of wrapping paper you would need so that you're not overlapping or anything extra to completely cover that shape. And that's probably the best sort of analogy of surface area. It's the smallest amount, the minimum amount of wrapping paper you need to wrap or to cover a 3D shape. Now, a more mathematical explanation would be that the surface area of a 3D shape is the total area of its net. Now, looking at the net of 3D shapes is what we look at here. So these are the common types of shapes that you're asked to work out the surface area of. So in a cube, you can see now a lot of when you're discussing nets of shapes, there are different arrangements of the net of the 3D shape that you're looking at. But again, it will usually consist of the same sort of shapes, just in a different sort of orientation. So with a cube, you usually find like a cross tends to be the common thing, and basically the surface area of the cube would be all of these areas added together. And then for a cuboid, again, if we break that net or break the cuboid up, we'd get, obviously here we've got 4 rectangles and 2 side squares. So the surface area for this shape would be that plus that plus that plus that plus that plus that. And then for a triangular prism, we've got 2 triangles and we've got 3 rectangles that would construct to make a triangular prism. Now for a cylinder, now this one's a little bit difficult to look at because if you look at the picture of a cylinder, you think, oh, that's one curve. But if you actually break it up, so if you imagine like a cake tin or a toilet roll actually would probably be a better analogy with 2 lids, then all it would be is a rectangle and 2 circles. And then for a square-based pyramid, you've got square, then obviously you've got the 4 side triangles that we then need to work at. And so the surface area is the total area. So it's kind of like adding all of those areas together. So for the cube, it's adding up those 6 squares. For the cuboid, it's adding those 4 rectangles, or potentially 6 rectangles, or even 2 rectangles, I should say. For triangular prism, it's a case of adding the 2 triangles and the 3 sides. For a cylinder, the 2 circles and a rectangle, and then for the square-based pyramid, it would be the 4 triangles and the square. Now, at high GCSE, you will be asked to work out the surface area of more complex shapes, such as pyramids, spheres, cones, and it's quite difficult to draw the net of those shapes, but there are formulas for these shapes that you will need to learn by heart. In some cases, it might be given to you in the exam paper, but sometimes it's not, which we will cover at the end of this video. Now, there are certain steps that you need to find the surface area of a common 3D shape without using a formula. So like I said, there's 2 methods you can use. One is using the formula and one is using the following steps. Now, the first step for you to do, and again, before I start, it might be worth you making a note of these. And again, when we go through some of the questions, I will explain what all of these steps mean if you are a little bit confused as you are writing and reading them. So the first step is to draw the 3D shape as best that you can. Now, often this is pretty much drawn for you, but if you were given a worded question where it says that to work out the surface area of a cylinder with radius of 5 centimeters and height of 6, and that is pretty much all the information you need to work out the surface area. And you might find it more beneficial for you to actually draw the 3D shape, if not to actually draw its net. Now again, it's another topic within itself, is net of 3D shapes. So again, what you want to try, and if I just move back up, if you can try and remember what the net would actually look like of the more common shapes of a cube, cuboid, triangular prism, cylinder, pyramids, etc., it will only go in your favor when it comes to actually working out what the total surface area is going to be. Now the next thing is to label each of the unique faces. Now you will find that on your 3D shape some faces will be the exact same and some will be completely different. Now what you want to try and do is label each of the unique faces so that you're not doubling the work up. So for example, recognizing that a cube is 6 of the same face, then rather than adding up 6 different areas, if I just work out the area of one square, I can just multiply it by 6, job done. The third step is to make a note of how many of each face that you have in the shape in total, which kind of blends in with step 2. And then for step 4 is to calculate individual areas for each face. Step 5 is then add them together. And then step 6 is the final thing, is don't forget the units, which is a very, very common error, and an area where a lot of students go wrong is forgetting the units. Now again, because we're working with area, it's going to be square units. So you're looking at millimeter squares, centimeter squares, meter squared, etc. So let's have a look at an example. So let's go straight into this one. So here we've got a cube and we want to work out the surface area of this particular cube. So here again, what we'll try and do is get an idea of the face. Now, there's a couple of ways in which you can do this. So if I just do a quick sketch, and it's not looking a great one, but it looks something like this. Now I've got 6 times, and then it's going to be one face. Now one face is 6 by 6, so it's going to be 36, or let me just avoid doing that. So it's 6 lots of 6 times 6, and then, which is what I need to work out. So if imagine I call this A, and that's going to be A, and then I'm going to have 6 lots of A's, and if A equals 6 times 6, then A is going to equal 36. So then what I've got is 6 times 36, and again if I type that into my calculator, 6 times 36, I get 216, meaning that the surface area for this shape is going to be 216, and then just checking the units, which is centimeter squared, and there is my final answer. Moving on to question 2. Now again, one thing you want to make sure is the first thing to check is, so first an important note is make sure all lengths are in the same units. Now we didn't have to worry about with the first example, with it being a cube, because obviously we only need to know one side, because in a cube all the sides are the same. However, when you have got multi-dimensional sides where the sides are going to be different, it's just something to bear in mind. And now, looking at this, a good question is do we work with meters or do we work with centimeters? Now, it doesn't really matter because we've not been asked to specify how they want the answer to the surface area to be written. Do they want it in meter squared or centimeter squared? So you can pretty much choose. Now, obviously, I've got 3 different measurements of a cuboid that I've got here. 2 of them are in meters and only 1 of them is in centimeters. So it probably eases my workload if I just change this and convert that into meters. So I ask myself, what's 200 centimeters in meters? Well, the answer is going to be 2 meters. So for this, what I'm going to do is I'm going to label the sides. Now, if you imagine, if I just do a quick sketch of a cuboid, like so. Now, what I'm going to have is I'm going to label the sides. So I'm going to label this side A, B, and C. Now, in terms of C, well, I'm going to have 2 of those because I'm going to have this top and that bottom. So the surface area equals 2 lots of C plus, and then if I look at this side here, which is my B, and this side here, so I'm going to have 2 lots of B, and I'm going to have, and if I look at the other side, so here I've got this side here and this side here, which is going to be A, and I've got plus 2 lots of A. Now working out the area of A, well, that's going to be 11 times 5, which is 55. And then working out the area of B, well, that's going to be 2 times 5. And so here we've got 2 times 5. And I've just noticed that that 2 centimeters looks like it's also the height. Actually, let's write it here. So it's 2 times 5, which is 10. And then finally the area of C, which is the top, and that's going to be 11 times 2, which is 22. Now from this, I'm going to use this formula, which I've kind of not written wrong, but I'm going to write it a little bit easier. So the total surface area is 2 lots of A plus 2 lots of B plus 2 lots of C. So the total surface area, which I'm just going to abbreviate as SA, is going to be 2 times 55 plus 2 lots of 10 plus 2 lots of 22. And again, if I work that out, I get 110 plus 20 plus 44, which gives me 174, and then the units are going to be in meters squared, and there is my final answer. Now moving on to example 3, and again what we're going to do here is I'm just going to do some projection lines of the shapes that we have got, like so, because it's always important that we kind of recognize the net of this triangular prism. Now it's important to recognize that in a triangular prism we've got 5 faces. Now again, if I try and just color code each of these, so again I'm going to label the faces, so let's go for black. So well, actually let's shade in the faces. So the first one I've got is this triangle here, and I've also got the triangle there. Might just have to ignore my colouring skills. And then for the next one I've got this side of the triangular prism, and I've also got that face there. And then I've also got the base, which I'm just going to do in green, which looks like that. Now in terms of labeling, now if I just draw that again, if I label this A, B, I've got another B on this side, I've got an A on this side here, and I've also got a shape C on there. So I've got 5 faces, and again if I was to look at the net of this, then what it would look like is it would look something like this. Now your nets don't need to be a work of art, but it's just a case of just working through it. So if I label the triangles A, I've got this side B and the bottom C, so that's going to be C, that's going to be A, and these are going to be my 2 B's. Now with a triangular prism you are going to have lots of measurements, but that's because you need a lot of measurements because we need to work out the area of each of those faces. So the surface area is equal to 2 lots of A plus 2 lots of B plus 1 C. Now the area of A is a triangle, so again I'm just going to write a triangle just to make it obvious, and then here we're again looking at the formula of a triangle. It's base times height divided by 2. So for this, the base of this triangle is 6, the height is 8, I'm going to divide that by 2, so here I've got 48 divided by 2, which is 24 centimeter squared. Now in terms of the area of B, well that's a rectangle, and that's going to have dimensions of 10 times 12, which is going to give me 120 centimeter squared. And the area of C, which is also a rectangle, has got dimensions of 6 times 10, which is 60 centimeter squared. So now using this formula that I've written here, I'm now going to use these numbers to work out what the total surface area is going to be. So the surface area is going to be 2 lots of A, which is 2 times 24, plus 2 lots of B, which is 120, plus 1 lot of C, which is 60. So working this out, I've got 48 plus 240 plus 60, which all added together gives me 348, and the units are going to be centimetre squared. So moving on to our fourth example, which is looking at a cylinder. Now, if you imagine and go back to the net of a cylinder, so just make sure that this is looking correct. So again, if I just highlight the faces that we can't see. So here I've got this face, this circle, and that's the same as the base. And I've also got this rectangle as well. So looking at the area or drawing out each of those, or the net of the shape, I should say. So what I've got is I've got two circles and a rectangle. Now to work out the area of a circle, it's pi r squared. And to work out the dimensions of a rectangle, that's just going to be the length times the width. Now, this is obviously going to be the height of the trapezium, of the cylinder, which is 20. Now, the question that a lot of students tend to go wrong is, what is this length here going to be? Well, if you imagine what connection does that line there have to the circle, well, that's got to wrap around the perimeter of the circle. So this line here, or this length here, I should say, is actually the circumference of the circle. And if you think back to what the formula of the circumference of a circle, that's going to be pi times d, or 2 times pi times r. So I need to work out the individual sections of this particular cylinder. So again, I'm going to label the sides. I'm going to label A, B, and A. So the total surface area is 2 lots of A plus 1B. Now looking at area A, which is a circle, that what I've got is pi times the radius. Now the radius of this is going to be, well, if the diameter is 8, then the radius is going to be 4. So here I've got 4 squared times pi, which gives me 16 pi. And again, I could stick that into my calculator, or I can leave it in terms of pi. So I'm just going to just quickly work out what 16 pi is, and that is 50.265482446. And then working out the area of B, which again, if I just draw a rectangle, so this is going to be 2 times pi times r, so that's 2 times pi times 4, or I could write it as 8 pi, and the height is 20. So working out the area, it doesn't really matter which one of these two I use, because they're both going to give me the exact same. So I'm going to go for looking at this one here. So what I've got is I've got 2 times pi times 4 times 20. And again, if I type that into my calculator, which I'm now going to do, so I've got 160 pi. And if I convert that into a decimal, then that equals 502.6548246. So then the total surface area is going to be equal to 2 lots of 16 pi plus 160 pi. And working this out, so I get 32 pi plus 160 pi, which equals 192 pi. And there is my answer in terms of pi. Now, if you wanted to work with decimals, which is sometimes the case, particularly if you've got a calculator paper, then all I need to do is do 2 times 50.2654 and all of those numbers, plus 502.6548246, work that up, and I get an answer of 603.2 centimeter squared, and that's to 1 decimal place. So if you have rounded, it's always good for you to state what your rounding has been, what your rounding is up to. So there I've just highlighted to 1 decimal place. So let's have a look at this. So like we talked about, that there are more complex 3D shapes that again tend to be more GCSE, and drawing the nets of these shapes can be a little bit more complex. So as well as drawing the nets using diagrams, you can also calculate surface area by learning and using the following formulas. So here what we've got is a cone. Let me just make the title a little bit there. Now, for the cone, you've got two areas. Now, if you imagine like an ice cream cone, that this bit here is the wafer, and you've got a hollow base. Now, to work out the area, the surface area of the sort of wafer for the ice cream cone, then what we need to do is we need to use this formula here, which is pi times RL. Now, R is the radius and L is the slanted length. Now, to work out, and then the base obviously is a circle. So what you'd have is, and again, I'm not going to embarrass myself by trying to draw the net. And then we've got the base, which is going to be a circle. Now, in terms of that, let me just make that a little bit, stand out a little bit more. There we go. And then we've got the base, which is going to be this bit here. And that there is pi times r squared. So to work out the total surface area, then that's going to be pi RL, remembering that L is not the height, it's the diagonal slanted length of the cone, plus pi r squared. Looking at a sphere, now the volume of a sphere, the surface area of a sphere is going to be 4 pi r, where obviously you've got the radius. For a cuboid, again, looking at this, well, the nice thing about a cuboid is that all the lengths are the same. So if I work out the area of that green section, well, that's just going to be L times L, so that's L squared. And because I've got 6 of the same face, it's going to be 6L squared. For a cuboid, that one's slightly different because I've got 2 of each face. So if I call this one, or colour this one in green, and then I colour this one in orange, and the top one in blue, that here I've got 2LW, LW is going to be this one, that's the blue. I've got 2 lots of HW, which is in orange, and I've got 2 lots of HL, which is in green. And again, you can work out and just learn these formulas to work through it. Now with a cylinder again, and that's going to be in terms of the curved surface area, which is this part here. Now, as we've talked about, that's what that there is going to be, because again, if you think back to what that curved area is, and again, let me just, so this curved area is actually just going to be a rectangle, where this is the perimeter of the circle, which is 2 pi r, and then you've got the height. So the total area of this green area is going to be 2 pi r times h. And obviously you've got the 2 circles, so the base and the lid equals 2 lots of pi r squared. So the total surface area of a cylinder, including the base and the lid, is going to be equal to 2 lots of pi r squared plus 2 pi r h. And there is your final formula for the total surface area of a cylinder. Now, it's important that you read the question carefully, because sometimes when you're working out the surface area of a cylinder, it might ask you for not the lid. It might not ask you for the base. It might be like a toilet roll, an empty toilet roll, I should say, where it's asking for how much cardboard you need to make that toilet roll sort of frame. So again, that would just be the rectangle, which the area would be 2 pi r h, and we go from there. Now, in terms of a pyramid, now this one's a little bit more controversial, is the fact that it's important for this that you recognize the net. Now, if you had a square base pyramid, well, that's going to be a square, and you've got your 4 triangles. So the total surface area of this pyramid is going to be the 4 triangles plus 1 square. And again, what you do is you work it out separately. So 1 triangle is going to be base times height divided by 2. And obviously the square is going to be L times L. Now, if you're dealing with a triangular base pyramid, then again, you've got 3 triangles, or should I say 3 side triangles. And you've got 1 base triangle. Now, when you've got triangular pyramid, you tend to find that the side triangles are going to be the same. However, the base triangle is going to be different. Or you might find that all the triangles are going to be different. So it's important that when you're working with a pyramid, I would probably recommend that you work out the sides individually and then add them all together. And again, uses of colours. will help you massively to gauge an understanding of each of those. And again, so if I just, there's the back triangle, and then we've got the base triangle, which is at the bottom there. And again, it just kind of helps. Now, recognize that obviously when you're doing a test, that any use of colors is not going to be included. It's not going to come up. So let's have a look at some actual examples and techniques of being able to do this without using the formula, just another method that you might want to use. So here we're using nets to find the surface area. So as we've talked about here, now again, when it comes to this particular shape, now if I just draw this potential cuboid out, so in terms of the lengths, we've got our lengths of 6, 5 and 3. So 6, 5 and 3, and then we can work out each of the individual faces. So you can see that we've got 2 of every single face, and then all they've then done is added it all together, and again you come out with the total area. So that area of 126 is made from 2 lots of 18 plus 2 lots of 15 plus 2 lots of 30, and that all comes up to a total of 126 centimeters squared. Now again, looking at a tetrahedron, also known as a triangular base pyramid, again all we've done here is worked out the individual areas of each of these triangles, and you can see that with the tetrahedron we've got 4 of the same triangle. So again, working out the area of a triangle, which is base times height divided by 2, or you could use half times b times h, which is what they've done here. So the total area of one triangle is 15.6, and as we've got 4 triangles, we times that by 4 and we get the total surface area, which is going to be 62.4.